Welcome to another great section of this wonderful tutorial class. Today we'll be introducing in course mathematics a topic called binomial theory. Binomial theory. Basically, so please ensure you don't distract yourself by anything at all. And please know you are not subscribed to this channel. Let's try and do so. So this class is going to bless you. So let's get to business. So look at it. I have two theorems here. The first thing is for you to understand the meaning of the two theorems and what are they used for. Now, if I have something like this in mathematics, let's say A times B raised to power, let's say M. So if we want to open this bracket, we're going to have A raised to power M times B raised to power n. So let's say we have 3 times 4 raised to power 2. This one gives us 3 raised to power 2 times 4 raised to power 2. Or like we have A plus B now raised to power n. If I want to open this bracket, how am I going to do it? Let's say A raised to power n plus raised to power n. Never. So this one leads also the one I call the binomial theorem. So if you have two things either being added together or subtracted from each other, and you want to expand it or open the bracket, you are going to use a theory called binomial theory. Although partial triangle will also work here. I will not do partial triangle today. I have done it before during our complex number class. Partial triangle will work here, but it won't work this week. So let's look at this first one, this first theory, the meaning and what is it used for. Then let's look at the second one, the meaning and what is it used for. So I'm going to be using a very plain and simple language to explain this. I don't know, so I use grammar or grammatical, mathematical words. No, we will use plain, simple way to do it. And look at it, a very simple way. If you have two things multiplied, added to each other or subtracted from each other, and you want to open the bracket, we're going to do it this way. The summation of arrows start from 0 to n. Look at the beginning of this. This one means arrows start from 0, 1, 2, 3, 4, 5 until you get to n. Then you solve. Times n. Now this one is just a statement. Remember this notation called sigma notation. Remember this one means if you put arrow as 0, before you put arrow as 1 again, you will use addition sign to separate arrow equal to 0 from arrow equal to 1. That is the meaning of that. That's the meaning of this symbol there. So this symbol is just a notation called the summation notation. It's telling us arrow is an index number. Arrow is not just one number there. Arrow starts from 0. I want to go and end at n, which is the power. N is the power. Arrow is the index that is moving from one number to another. So if you put arrow as 0, you solve it. Put arrow as 1 again, you solve. Now before you write arrow as 1, separate the 2 with a positive sign. Before you write arrow equal to 2, separate it again with a positive sign until you get to the last value of arrow and you stop. The A is the first term here, first number here. The B is the second number here. But this must be 2. By with 2. If it's 3, we separate it and to like use bracket to arrange it to be 2 first. You have one T here and that thing there. So if you have like this is the first term, the second term. So you be n combination. Arrow, what is arrow? Arrow is not here. Arrow is any number that start from 0 until you get to the power. That's arrow. Then times A, which is the first number here, raised by this n minus this any number which is arrow that start from 0 to the power. Then before you get to B, times B now, raised by that arrow we're talking about. I'll show you where to get arrow from, or how to get arrow from this example now. You understand it very well. But remember that. Okay? Then this will only work perfectly well if n is a positive integer. This theory now will work very well if n is a positive whole number. But if n is a negative number or a fraction, let's say n is a negative number or n is a fraction, then we are good. This series expansion will be proper or more lovely to solve the problem. Now, before you can use this expansion, you will ensure that your A is equals to 1 here. But even though your B is not X, anywhere you see X in this place, you can place the actual value of X. For example, now, for this one now, if A is equal to 1 and B is equal to X here, but N must be something like a negative number or a fraction, then we use this. So if N is a negative number or N is a fraction, I'm going to respond to this way. But ensure that your A is 1 and your B, even though it's not X, for this one B is X. So if B is eventually B is now, let's say X over 2. You change this X to X over 2, change it to X over 2, change it to X over 2, but ensure that your A is 1. For this one to work properly, ensure that the A is 1. So for this first one, for this same one, we make our B to be X. So after we have done a lot of examples, for example 124, you understand it better. But this works if N is either a negative number or a fraction, we use this. But if N is a positive whole number, we use this one. So please take note of that. But ensure that your A is 1 here. That is very important. So let's get to this first example. Example 1. Now for this example now, you check, if you compare this to this, our N is equals to the power is 3. Is it positive whole number? Yes. So this will work, not this. Then our A is equals to 2. Then our B is equals to X. So from this formula now, we have N combination R. Now what is now R? Our N is equals to 3. We do get R from N. If N is equal to 3, R will start from 0 and end at N. R will always start from 0 and you will go and end at N. So look at R is inside this question. You always get to R from this power. R is any number that will start from 0 to the power N. So R will be 0, 1, 2, 3. Then R will end at 3. Why is it ending at 3? Because our N is equal to 3 here. Take note of that. So from this formula now, you just omit this demonstration. I'll show you what this one is saying. I already showed you before you put the second value of R, separate the two terms with an addition sign. This one will be equal to N combination R first. N, what is N? Series combination. Let's take R to be 0 first. The first value of R is 0. Then times. Then what is A? A is, let's use the other symbol for combination. That will be more simpler. Let's say series combination 0. And that is more lovely. Then times A. What is A? A is 2. A raised to our N is 3 minus R 0. Then times, what is B? B is X raised to our R, which is 0. So if you pick R at 0, put it into this formula. Put 0 here, put 0 here, put 0 here. A from the question A is 2, put 2 here. B is X, put X here. Then N is 3, put 3 here. Place 0, 0, 0. Then, R is equal to 2 now. Come back to this place again. R is equal to 2. Come back to this place again. Change arrow from 0 to 2. You are going to have 3 combination. Okay, R is equal to 1 first. Sorry, don't go to 1 first. You now have 3 combination. Change arrow from 0 to 1. 1, then 2, then 3 minus 1, then X is power 1. You see? I've changed arrow from 0 to 1. Now, what is this sigma talking about? Before you change arrow from 0 to 1, separate this from this with an additional sign. That's what I want to say. Then, before I change arrow now, from 1 to 2 again, I will separate it with an additional sign again. That will be N combination. Change it to 2 again now. Then 2 is power what? Then 3 minus 2. Then X is power what? 2. Then what is the next value of arrow? Change it to what? 3 again. Before you do it, plus 3 combination 3. Then our 2 raised power. Then 2 raised power 3 minus 3. Then X is power 3. That is the last number of arrow. I don't know if you can get it. Our A is 2. A is always 2. A will not change. Anything inside the question will not change. The only thing that will change it will be R. R will change from 0 to 1 to 2 until you get to the value of N and you stop. So let's simplify this one now. This is expansion. We put this bracket, one expansion, and this is what we are doing here. So let's simplify to see any number combination. So remember it's what? It's 1. Then times. Then 2 raised to power 3 minus 0 is 3. then times, then x equals 0. Then a number raised by 0 is 1. Then plus any number combination 1, remember is that number itself, times, then 2 raised to power 3 minus 1, 2. Then times x equals 1 with x. Then plus 3 combination 2. Let's do that one. 3 combination 2. 3 combination 2 will be equal to, from the combination class B, that will be 3 factorial over 3 minus 2 factorial times 2 factorial. That will be 3 factorial. 3 minus 2 is what? 1 factorial times what? 2 factorial. That will be 3 times 2 times 1. Over 1 factorial is 1. 2 times 1, that is 2 factorial. 2 cancel 2. 1 times 1, 1. Then 3 times 1, 3. Divided by 1, 3. Cancel 3. So 3 combination 2 is 3. You have done the combination class. You know you have not watched this combination class. Please go back and watch it. It's very, very important. When you do this one, go back to combination you did. Then 2 raised to power 2 minus that is 1 times 2 raised to power 1 times x to power 2, that is x squared. Then plus 3 combination 3. Anything combination itself will be 1. Then 2 raised to power 3 minus 3 is 0. Then x to power 3. So this one will be equal to, that will be equal to 2 times 1. Okay, 1 times 1 times 2 raised to power 3 is what? 8. That will be 8. Plus 2 raised to power 2, 4. 4 times 3, that will be 12x plus 2 raised to power 1, 2. 2 times 3, 6. Times x squared, 6x squared plus 2 raised to power 0, 1. Anything raised to power 0 is 1. So 2 raised to power 0 will be 1. 1 times 1 times s cubed. So this is what you are going to have. You simplify the expansion. 8 plus 12x plus 6s squared plus s cubed. So our first term is 8. The term independent of s here now. The term I don't have s is 8, which is first term. Second term, third term, fourth term. They can ask you, in this expansion, in the expansion function now, what is the equation of s squared? The equation of s squared is 6. You go in this class, we're going to do more class. This one is just first class. So ensure you understand this one very well before we move to the next one. So let's look at this number 2 question. Remember what we did. For this question, when you compare this to this, okay, let's check. Let's check. Our A is equal to 3, B is equal to equality. B is not equal to S, B is equal to minus S. This minus will affect the S. B is equal to minus X. Then N is equal to 3 as well. N is equal to 3, B is equal to 3, B is equal to minus X. Now what will be R? Who can tell me R? What will be R now? Remember I told you R will start from 0 and end at N. So R will start from what? 0 now. 1, 2, 3. You go and end at 3. Please take note of that. Very, very important. So we now have something like this. Now for this formula now, N combination R first. N combination R. Now R is 0, 1, 2, 3. We're going to take R as 0. Now R is equal to 0 now. We will have N combination R. That is N is 3 combination R. And R is equal to 0, from 0 here. Then times A is 3. This is our N minus R. Then times B minus X. This is our what? R, which is 0. Use it. Go to this formula. This formula that I'm using. This formula that I'm using. Remember, N combination R is 60 as this. N combination R. So I do it like this. N combination R. Or also do it like this. N combination R. Any of them is correct. Please, if you know you have not watched our combination class, go back and watch it. This one I can write this one this way. I write this one this way. I write this formula this way. Summation of R start from 0 to N of N combination R. So if I tell you that we use one now, A raised to power N minus R, then B raised to power R. Let's write it this way. So instead of using one, I can use this one. That is what's in there to write. That's why I'm using that in solving. So the plot for you. But we're going from after we have you just forget about this sigma. This sigma means before you put arrow as 1, separate the 2 with an addition sign. So N is 3, arrow is 0, 0, 0 for first. 0, 0, 0. A is 3, B is minus first. Then now go to the next line of arrow, which is 1. Then go to this place and put arrow as 1, 1, 1. Then we have. Before you put arrow as 1, 1, this one is have 3 combination 1, 3 raised power 3 minus 1, then minus x raised power 1, and plus, and 3, arrow at, move to the next arrow at 2, and 3 raised power 3 minus 2, then minus 1 x raised power what? 2, plus, then the next arrow is what? 3 combination, next arrow is 3. Then 3 raised power 3 minus 3, then minus x raised power 3. And that is the last one. It's a very simple thing. What you have to do, go to the formula, forget about this sigma notation, just go to this formula, substitute the value of A, N, and B. The arrow will now be, take the first value, 0, 0, 0. After you have substituted arrow, take the second value, the 1, 1, 1, 1, 1, 1, and 2, 2, 2, 3, 3, 3. That's it. All other things remain the same. Practice remain the same. So let me take this one downside. Remember, question 3 was 1 over 1 plus x. So do that. So let's go. Then we'll be having 3 combination 1, 3 raised power 3. Then any 3 raised power 0 that is not 0 is 1. So minus x power 0 is 1. Then plus 3 combination 3 times 3 raised power 2. Then minus 1 raised power, any 3 raised power 1 is that same number, minus x. Then plus 3 combination 2, also be 3. I've solved it before in our first question. And 3. Then times 3 raised power 1. So 3 minus 2 is 1. Then a negative number raised power even number will be positive. Look at that. If you have a negative number raised power of even number, that's will be positive. So times s squared. So what we are trying to say, if you have minus s now, raised power 2. 2 is an even number. So this minus will turn to positive. So that's what we get. Then plus the next one, 3 combination 3, 1, 3 raised power 0, then times a negative number raised power odd number still remain as negative. So it will give us, I think we'll keep this question first. So this will give us 3 times 3 raised power 3 times 27 times 1, remain the same. And minus times plus, minus 3 raised power 2 times 9. 9 times 3, that's also 27. That's also 27. Yes. Then 3 raised power 1 times 3 times 3, 9 plus 9s squared. Then minus times plus, that will be minus 3, any 3 raised power 0. 3 raised power 0 will be 1. The number is not 0. 1 times 1, 1. Minus times plus, that is minus. 1 times 3 raised power 3, that is s power 3 plus s power 3. So I'll give the expansion. 27 minus, let's check. 9 times 3, 9 times 3, that's 18. 27 is correct. So I'm going to have 27x, and 27x plus 9x squared, and 9 times s cubed. Remember, the third question was 1 over 1 plus x, 1 plus x. So how will we expand on the next question I will do there? How will we expand this? So before we expand this, I'm going to transfer it such that the question will have the power. And first we are going to transform it such that the question will have the power. So we have to play this 1 plus x raised power minus 1. Because look at it. Any number 1 over, let's say a now, sit here as a raised power minus 1. You have 1 over the number, means that number raised power minus 1. That's the mean. If I ask you now, what is, let's say 1 over x plus 3? It means x plus 3 raised power what? Minus 1. That's the mean. So if I have x plus 3, now what do you have x plus 3? Okay, I like to write this one, write x plus 3 raised power what? Negative 1. So 1 over 1 plus s, see it as 1 plus s raised power what? Minus 1. So if you look at this now very well, this one not have the power, this one is having the power. Check the power. The power which is n is equals to what? Minus 1. Then the first term here, which is a, is 1. Then the second term b, which is x. So this one satisfies the second formula, which says that if n is a negative number or a fraction, we should use this. And a should be 1. Then even though b is not x, I'm not going to rectify that. Or a should be 1. Then n should be a negative number or a fraction. So this is what we're going to do there. So we're going to use this one now for a second. Since n is a negative number, so we're going to have. So we have 1. First one is 1 plus nx plus nx. Nx, b is x, is correct. So n is negative 1, x, then plus n bracket n minus 1, n is negative 1, negative 1 negative minus 1, over 2 factorial s squared, then plus, got space now, I cannot write this because this thing is still going, it's infinity, just dot, see infinity. So we're going to have 1 minus 1 times plus will be minus x. Then plus minus 1 times minus 1 minus 1 times minus 2 over what is 2 factorial, that is 2 times 1 x squared plus all the rows. That will be 1 minus x. Then minus times minus, that will be plus 1 times 2, that is 2 over 2 x squared plus all the dots. That will be 1 minus x. 1 cancel this, that is 1 times x squared plus x squared. So maybe the next regular number will be negative. So that this will be the series expansion of 1 over 1 plus x. It's a very simple thing to do. Very simple as that. So there's a fourth question here, which is the root of 1 plus x. Think the root of 1 plus x. The root of 1 plus x. That will be the root of 1 plus x. So 1 plus x. So let me clean this place to do that there. Let's do that. So, if you want to do the root of 1 plus x now, there's no power here. But remember that the same way we have 1 by the number, which means that number is power minus 1. The same way we have the root of the number means that number is power half. That is the root of the number. Because the nth root of a means a is power 1 by n. So the root of the number means the number is power half. So the root of this number means this number raised to power 1 over 2. That is the meaning. So that's right to 1 over 2. So in this place now, our n is equals to 1 over 2. Our a is equals to 1. B is equals to x. B is equals to x. So for this, for us to solve this very well, since n is not a good number, it's very good for us to use the second formula. Very good. A is 1, very good. B is x, still very good. Still very nice. So if you want to do that now, we are going to have 1 plus nx. Remember, 1 plus nx. What's n? Half x. Then plus n bracket n minus 1. N is half. Bracket half minus 1. x squared over 2 factorial. Then plus dot dot dot. You can do the other one if you wish. And that will be 1 plus half x. Then plus half times. What is half minus 1? That's minus half over 2 times 1 x squared plus dot dot dot. So this will be equal to 1 plus half x. That is plus this one times this, that will give us minus 1 over 4 over 2. 1 over 4 over 2 x squared plus dot dot dot. So this will give us 1 plus 1 times x. Half x means x over 2. That is the meaning. Then minus times plus minus. So look at this. If you have this, you're having 1 over 4 divided by 2. 1 over 4 divided by 2. That is 1 over 4 times. Take the reciprocal of this 2, that is 1 over 2. That will be 1 over 8. So this is simple as, or you just say 4 times 2. That will give us 1 over 8. 4 times 2 is 8. S squared plus dot. So it will be final answer will be 1 plus x over 2 minus 1 times x squared, that's x squared over 8 plus dot dot. So this will be the final answer. So that's expansion of square root of 1 plus x. So this is what we have. You can have the next step. Once you wish to do the next one now, to see what you have to do, just do half times half minus 1, half minus 2, x cubed over 3 factorial. You also have that there. So in our next class, we'll do more. Our next class, do more. So I'm going to stop here for now today to ensure you watch this video over and over again in order to get the full details of the class. So this is introduction, just an introductory class to the binomial expansion. So next class we're going to do other important aspects of this topic. So see you guys in the next class. God bless you. Thank you.